Welcome to this video of Incredibuild in action. The following demonstrations will be showing you the power of and ways you can easily utilize Incredibuild in your environment. Let's step into the first pattern of use and demonstration of Incredibuild. Incredibuild can seamlessly be brought to bear by simply wrapping the command that will be running the build. For our first example, we're going to create a debug build utilizing CMake and Ninja and make it go fast. How do you measure fast though? For reference, when we ran this debug build on a single 4-core machine, it took 17 minutes and 10 seconds for the compile to complete. This is going to be our baseline benchmark for all builds we will run today. Now we'll run Incredibuild from the command line to start the acceleration. Build console is the name of the executable we are calling from a CLI. We simply change into our build directory, which you can see here, we're in x64 debug ninja, and then wrap build console around the CMake build command. Once we hit enter, the magic will begin to happen. Now, what's happening under the covers is our process virtualization has intercepted the build request and is now managing all the steps of the build on your behalf and distributing it across the grid. As this builds, let's go over and look at some things that are happening in the coordinator. Now, there's 3 main components to Incredibuild. There's the coordinator, which we have here. You can think of that as similar to air traffic control. It knows everything about the compute grid you've created, which machines are initiators, which are helpers, and what capabilities that it may have to offer. The next component is the initiator. This is the machine that actually starts the build. So the machine that we just kicked off that command, this is our initiator. When a job kicks off, the initiator talks to the coordinator to tell it that it needs resources. The coordinator looks at the last component, aptly named helpers, to know which ones are available to distribute tasks to. So in this case, we have a total of 5 servers. We have 1 coordinator, 1 initiator, and 3 helpers. Now, all total, we have 20 cores. And because they are all designated as helpers as well, all those cores are now being consumed as part of that build. So the coordinator is what allows you to centrally manage your grid. It gives you an overview of what's occurring in your environment right now, where we have online 5 machines. We currently are using 20 cores. We have 1 build going. And there's licensing and other information about the total amount of cores that we could use. The other thing that it also offers you is the ability to centrally manage your environment. So if I wanted to come in and look at a machine, I can tell instantly that helper 1 is using this type of CPU info of an Intel Xeon. I can look at the OS version it has, network information, and things along that nature. Now, because we're centrally managing from the coordinator, I can also begin to select and make changes to the configurations that I need to all at once. So I can select an individual machine, or for the power of making things simple, I can select everything, and then I can begin to make my changes that I want to, if I need to change a license configuration, or if I want to begin to shape how my build works by making build groups or assignment priorities. All of this can be done centrally and very easily. The other key capability that Incredibuild offers is visualizations. As the build is in motion, we can graphically show you how the distribution is running via the build monitor. Now, it breaks down and shows you which machines are participating in the build currently, if you see here on the left, and gives easy to consume colors to know the status of the tasks. So green are tasks that have successfully completed, purple here are actively processing tasks that are being distributed. Now, cyan or this light blue are linking operations. Linking will always occur only on the initiator because it has more of a high I/O and not so much of a network requirement. Yellow are for tasks that completed but had warnings, and red, well, obviously that's for an error. Now, the other great thing that the visualizations will show you is not just how things are building and how they're being distributed, so I can see maybe I've got dependencies that I want to change or something along those lines, but I can also get graphs where I can remove or add elements of interest. So for instance, this is already showing ready tasks versus active tasks. Now active, there's the red line here that shows I'm pretty much consuming all of my cores available. But at that point, I had 83 tasks that were still waiting to run. If you come over here, I'm actually even higher where I had 351 tasks. This can give you an indication that you could probably consume and utilize more cores to help this build even go faster. The other thing that we can also do is, as you see in the background here, we have everything that is occurring, which we're almost done with our build, but everything that's occurring is also being repeated here. And then when it has just completed, I can come here and get a build summary. So for instance, this build took me 4 minutes and 13 seconds. Now remember, our baseline was 17 minutes and 10 seconds. So really what we're looking at here is we're a little over probably 4 times faster with Incredibuild just distributing across 20 cores. And you could probably look at that. I think if we run math, we're looking at about somewhere in the mid 70, 76% in a reduction in build time. So command line is pretty straightforward, but most developers today utilize some sort of IDE to interact with their code, with Visual Studio being very popular for C++. Another way we design to keep things simple and seamless is the fact we have built native integration with an extension plugin for Visual Studio. Incredibuild has a strong partnership with Microsoft. In fact, we're one of the few commercial tools bundled with Visual Studio. This extension can be easily installed either by the Visual Studio installer or at the time of installation of the Incredibuild agent on a machine that already has the IDE. So if we look here in our extensions, you'll see that we have Incredibuild installed and enabled, and then I can easily come down here and pick which things I would like it to do. If I have a solution, I can build, rebuild, clean. I could do the same thing for projects. I can come in and select the agent settings for the local machine. I can even come in and set extension settings. We're also going to enable and add in our new functionality of Incredibuild 10, the build cache. For this demo, we've assigned the functionality of the build cache to this initiator already. And although agents are centrally managed, they can also be configured at the local level to allow you to be more granular in control if you need. Here we're going to enable the build cache, and then we're going to kick off the build via the native integration with Visual Studio. So we've enabled, we're going to click OK. Okay, while it fires up, we're also going to open the build monitor of the same build that was done without the benefit of the build cache initially to show some comparisons. Now remember we said we could save files off so we can share this. This is exactly why we want to do this. If we look at these two differences here, this one currently is only running on 4 cores. Now this one looks very similar to that command line build we ran earlier. What's interesting to note is that the build completed again in the 4-minute range. There's an additional post-build step that the very first time a build is completed when consuming build cache. So Incredibuild is capturing the file results, what we call the metadata, and populating it into this new cache. Now, one way we can definitely tell that is when we talked about our systems graphs where we can come in and look at things. I can come down to the build cache and I can look at the two aspects here and say the cache hits stayed 0. I know it wasn't trying to consume it. The task to cache, though, kept rising as it was building, especially as it was doing its build outputs. Now, this metadata will be used and compared to for every subsequent build of that type. So again, if we come through and rerun like we're doing right now, whether we initiate by the plugin or command line or any other method, the very first thing Incredibuild will now perform, instead of just directly distributing the compute, is to check the cache to see if we can identify and pull what we need from there. Now, if the object file is found to exist, its hash is compared to the hash of the file being requested to build. If those hashes match, then there are no changes on the object and Incredibuild will consume it from the build cache. Obviously, if there's a change detected, then the decision is made to parallelize and distribute that task. Now, using the build monitor here, you can see that for this build, Incredibuild was able to hit the cache instead of miss it. So if we watch, in the distributed monitor, you can see a divergence of tasks. Now this indicated earlier here that there's probably a pretty good indication that we needed more resources. Now with build cache, divergence in the system graph is a good thing to see. It indicates that there were no changes from our previous build and thus nothing needed to have process distribution. Now if we look at this one, this completed in 2 minutes. Right about 2 minutes and 1 second. So if you consider our original 17-minute, 10-second build, we distributed our acceleration to right around 4 minutes just using the 20 additional cores, and we saw a little over 4 times the acceleration. When we combine that with our build cache, we just came in to just a hair over 2 minutes. So that really means now we have 8 times the acceleration of our single machine build. And realistically, the reduction in build time is around 88%, We thank you for taking the time to hear about and see Incredibuild in action. And at the end of the day, you as a developer or QA engineer or SRE need to save time, and you don't want to have to change your existing tools, methods, and processes. And that's exactly what we've shown today.